Let A is equal to R minus 3 and B is equal to R minus 1. Consider the function defined from A to B, where A is a domain and B is codomain, defined by f of x is equal to x minus 2 upon x minus 3. So here x is not equals to 3, that is R minus 3. We have to show that f is 1 to 1 and onto. For 1 to 1, so 1 to 1 definition, let me write here. We have two cases to prove it. F of x1 is equal to f of x2 implies x1 is equal to x2. This is how we can prove it. Or else another definition, for x1 not equals to x2 implies f of x1 is not equals to f of x2. So let us consider for 1 to 1. First definition, let us consider f of x1 is equal to f of x2. Consider f of x1 is equal to f of x2. So we can write x1 minus 2 upon x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. So cross multiplication, x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. So on simplification, x1 x2 minus 2x2 minus 3 times of x1 plus 6 is equal to x1 x2 minus 2x1 minus 3 times of x2 plus 6. So on simplification, x1 x2 x1 x2 on both the sides with the same sign gets cancelled and 6 also gets cancelled. The remaining terms we can bring minus 3x1 and here it is plus 2x1 is equal to, and here we can write minus 3x2 and plus 2x2. So we can write minus x1 is equal to minus x2 or x1 is equal to x2. So we got the condition for f of x1 is equal to f of x2, x1 is equal to x2. So we can say that f is 1 to 1. So the first function, the function given function is 1 to 1. And now and coming to the next onto, so the definition of onto says if codomain function that is b is equal to range of function that is y or f of x. If we can prove that the range of the function is codomain that is b r minus 1, we can say that the given function is onto. So now let us consider y is equal to f of x, which is equal to x minus 2 upon x minus 3. So on cross multiplication, we can write xy minus 3y is equal to x minus 2, or we can write xy minus x is equal to 3y minus 2, or x taken common y minus 1 is equal to 3y minus 2, or x is equal to 3y minus 2 upon y minus 1. Clearly we can say that the y cannot be equal to 1. Y cannot be equals to 1 means y belongs to r minus 1. Since for every y belongs to r minus 1, there exists second, right? For every y belongs to r minus 1, there exists x belongs to r. We have some real number except 3 such that f of x is equal to y. And here we can say that r minus 1 is nothing but your codomain. So here range is equal to codomain, and hence we can say this function is onto. So f is 1 to 1 and f is onto, so hence proved.